So a lot of us totally messed up on this part of the test. It was a test, right? And the truth is we're going to be needing to know how to graph lines for this next section as well. So that's why I want to go back and review this graphing portion. Okay, so it's going to be on the next test that we have. We need to know it. So before we even begin graphing, we need to know slope-intercept form. And again, the word form just means the way it looks, the appearance, the organization of the equation. And how does it look? Slope-intercept form is y by itself, y equals, and then you have your m, and then x. So it's m times x, and then plus b. Now it could be plus b, it could be minus b. We just usually write it as y equals mx plus b, but just remember that b could be negative. Anyhow, the slope tells you the steepness of the line. Okay, so we tell about the steepness with the fraction rise over run. It's just a little review for all of us. Okay, so rise means that it's going up. That's if the numerator is positive. But then again, the rise could also be going down if the fraction is negative. Okay, so keep that in mind. The rise could be positive, the run could be negative, but the rise could be positive or negative, but the run, we always want to look at it from left to right. We always want to look at it in the positive direction. Okay, so this is what we need to know with regards to slope, that it's a fraction rise over run. Okay, and the b value, that's simply our y-intercept value. Okay, so what is the y-intercept? It's simply where it crosses the y-axis. Okay, so we already know about standard form, which is capital AX plus capital BY equals capital C. That's good for finding the x and the y-intercepts. But slope-intercept form is the best form, y equals mx plus b, to graph the line. Because if it's in this form, you'll right away be able to look at this last number and tell where it crosses your y-axis, because this is the y-intercept. And then you can look at this fraction and tell from that point how much you rise and how much you run. Okay, so if we take a look at number 1 over here, we have y equals negative 1/2 x plus 3. Actually, it's not number 1, it's number 17 from our test. And we could clearly see that the m value is negative half. That's the m, right? We have y equals mx plus b. So the b value is obviously, the b value is obviously 3, positive 3. So if you know your m and your b, you know where it crosses the y-axis. Where does it cross the y-axis? 3. So you put a dot right at 3. That's where it crosses the y-axis. And then from that point, I'm either going to go up or I'm going to go down. It all depends on your slope. Now, what is the slope? It's 1/2. It's negative 1/2. Because it's negative, you're going to be going down. So instead of going up, you're going to be going down. How many units? It depends on your numerator, which is 1. So I'm going to be going down 1 unit, and I'm going to be going over to the right 2 units. So I put a dot right here. Let me do that. Put a dot right there. And all I need to do now is draw my line, put some arrows. Whoa, that's disgusting. Put some arrows on it, and I'm done. Now, if you wanted to extend your line further, you could always use the same slope pattern, down 1 over 2, down 1 over 2. So you could put a dot right here if you wanted to. Or you could go backwards, over 2, up 1, over 2, up 1, over 2, up 1, and put a dot here to make your line really long if you wanted to. You don't have to. Is there other ways of graphing it? Of course, you could make an XY table. You could plug in some 3 easy inputs, pull out outputs. But this is the quickest and best way to graph. Let's move on to number 18. So 17 was just worth 1 point. 18 is worth 1 point also. 18, where does it cross the y-axis? What's the y-intercept value? Negative 1, right? So this is your b value. And how about, let me actually put a dot at negative 1 on the y-axis. That's where it crosses. So the thing is this. Your line might cross going down really steep, or it might be going up really steep, or super steep. It all depends. How do you find your steepness? You look at your slope. So your slope is the fraction in front of x. That's your slope. And notice I said fraction in front of x. So 3 is not a fraction. You could make it look like a fraction by putting it over 1. So now you know that from this point, I'm going to go up 3 and over 1, and put a dot right there. Now, why did I go up 3? Because it's a positive slope. So you go up 3 over 1. And you just connect your dots, and you're done. Put some arrows on it. You graph your line. Easy stuff that we all, every single one of us, need to know how to do this. All right? Now, it gets a little bit more interesting on number 19, because number 19 is not in slope-intercept form, y equals mx plus b. See, and you can't even write, you can't change this to make it look like this. You can't do it. Why not? Because in order for you to get in slope-intercept form, you have to get y by itself, right? And right here, there is no y. So the only thing that number 19 cares about is that you understand that your x value has to be 2. Your x values have to be 2. So if you were to go back to the original way that we learned how to graph an input-output table, an xy table, and now remember, we would plug in any numbers we want for x, but in this case, x has to equal 2. So what we're going to do is simply plug in a 2 for x, a 2 for x, and a 2 for x. As many 2's as you want. Now, how about y's? Well, there are no y's in this equation, so y doesn't matter. You could plug in any numbers you want for y. So if I plug in a 0, a -1, let's say a +2, those are all coordinates that work for this equation x equals 2.
So because there's no y.
So if we go to these coordinates, check it out. If we go to the coordinate 2, 0, 2 on the x, 0 on the y, there it is. If I go to the coordinate 2 on the x, -1 on the y, it would be right here. If I go to the coordinate 2 on the x, +2 on the y, it would be up here. So what kind of line do we have? We have a perfectly vertical line. So this is all stuff that we should have known for the test. If you messed up on it, or maybe it was too long of a break, you forgot about this stuff, that's why we're reviewing this right here, because we need to know this skill of graphing with y equals mx plus b on the next section. Right? If you don't understand it right now, you're not going to be able to pass the next section. So let's make sure we understand y equals mx plus b. But we didn't even use y equals mx plus b in this case. It was just x equals. And of course, if you need more help, please go back and review the videos from the week before we got out on break, and that'll really clear everything up. Now this next one's 2122. It's worth 2 points. Why is it worth 2 points? Because it's in standard form. It's not in slope-intercept form. So maybe you want to get it in slope-intercept form by changing and getting the y by itself and then graphing. So that's why it's worth 2 points, because you have to change the whole equation. Or you could also graph it using standard form x and y intercepts. So let's go with x and y intercepts. Just as a refresher, in case you forgot, I always say write x int, y int, squiggly line, show your work. So to find our x-intercept value, we're going to set y equal to 0 and solve. To find my y-intercept value, I'm going to set x equal to 0 and solve. Okay, so these are just notes of what you need to know in order to find the x-intercept. This is what you need to know in order to find the y-intercept. And now let's actually do it. Let's take this original equation and let's rewrite it. But instead of y, I'm going to put 0. 6x plus 3 times 0 equals 6. So of course 3 times 0 cancels out. I really have the equation 6x equals 6, which means that when I solve for x, I divide by 6 and divide by 6. X equals 1. Now what did we find here? We found the x-intercept value. The x-intercept value. What does that mean? I found out where my line is going to cross the x-axis. So here's the x-axis. It crosses at 1 right there. So I need to put a dot right there at 1. Now let's go for the y-intercept value. Let's see where this line, whoops, probably shouldn't have done that. Let's see where that line crosses the y-axis by setting x equal to 0. So I'm going to set x equal to 0. It's going to say 6 times 0 plus 3y equals 6. Again, here's x, and I know to find my y-intercept, I need to set x equal to 0, so I put a 0 right here. And that's what it says, 6 times 0 plus 3y equals 6. Now 6 times 0 is 0, you could just scratch it out. You have the simple equation 3y equals 6. So if you divide by 3 and divide by 3, y equals 2. And this is the y-intercept value. So here's my y-axis. I know that it's going to cross the y-axis at 2 right here. So I put a dot at the y-axis at 2. Now, see, a lot of people did this correct work, and then they said, oh, x is 1, y is 2. That must mean that you have the coordinate 1, 2. Totally wrong. Those are not coordinates. It's not an x value of a coordinate that you're finding, or the y value. You're finding the x-intercept and the y-intercept. If you actually wanted a coordinate for the x equals 1, remember your x value is 1. Your y value you originally set equal to 0. So if you wanted it as a coordinate, you'd have to put a 0 right here. If you wanted this one as a coordinate, it would be 0 for x and 2 for y. Okay, but anyways, just with the x equals 1, you know it crosses here. Just with the y equals 2, you know it crosses there. And now we could actually draw a line going right through it. And of course, if you wanted a longer line, just keep going with your slope pattern. And right here, I'm looking at my slope pattern is down 2 over 1, down 2 over 1. And I could extend it as far as I want. Put some arrows on it, we're good. Now, of course, I could have done this whole problem differently. Now, what do I mean by differently? I could have taken this equation, let me just show you quickly. I could have subtracted 6x right here and subtracted 6x over there, and I'd have a new equation that says 3y equals negative 6x plus 6. And then I could have divided everything by 3, and I'd have an equation y equals negative 2x plus 2. And that's in slope-intercept form. Y equals negative 2x plus 2. So let me zoom out of this. And because it's in slope-intercept form, now I know where it crosses my y-axis at 2. See, it crosses at 2. And now from that point, I know it's going to go down 2 over 1, down 2 over 1. So that's yet another way of graphing it. You don't have to do both. You just have to pick one. But I just wanted to review x and y-intercepts. Now on this one, number 22 and 23, if you try to do x and y-intercepts, they both cross at the origin, so it doesn't help you at all. Okay, so right here, it's actually best to rewrite it in slope-intercept form, y equals mx plus b. So I'm going to subtract 3x, y equals negative 3x plus 0. We didn't have to put the plus 0, but that's just a reminder that our b value is 0. So in this case, our m value is negative 3 over 1, and our b value is 0. So where does this line cross the y-axis? What's our y-intercept? At 0. So if you put a dot right there, now from that point, what do? Do I go up or do I go down? Down, because the slope is negative. So you're going to be going down 3, 1, 2, 3 over 1. You always go run to the right. So let's put a dot right here. Then I connect the dots, and I'm done. You see, it's easy. 24, 25. Now this one's just, it's not in standard form. It's not in slope-intercept form. This one's just messed up. You need to rewrite it in the form that you want. So the best form is slope-intercept form, which is y equals mx plus b. So let's do that. Let's get the y by itself. So y is clearly on the left side of the equal sign. Let's get the y by itself. I'm going to subtract the 2 to get rid of the plus 2. So when you minus 2 plus 2 is 0. I'm going to put a line through it. What you do to one side, you do to the other side. Subtract 2 on the other side. Let's rewrite our equation. We have 3y equals 6x minus 3. Final step would be to divide by 3 to get rid of that multiplication of 3 in front of the y. Divide by 3, divide by 3, divide by 3, everything by 3. Our final slope-intercept form equation is y equals 2x minus 1. Now it's clear that my b value is negative 1, and it's also clear that my m value is 2. However, I want it to look like a fraction, so I'm going to put it over 1. So it crosses at negative 1, and then from that point I go up 2 over 1. Final step is to draw a line right through it, put some arrows, I'm done.